Okay, so how do we add or subtract a rational expression without a common denominator? First, what we're going to do is we're going to find a common denominator, just like we used to with fractions in the past. We're going to rewrite the fractions using the common denominator. Whatever you do to the bottom, you have to do to the top. Then we're going to add, subtract the numerators and keep the common denominator. And we're going to simplify if needed. So before we actually get into that, I want to just give you a quick review. When we had a question like 1/3 plus 1/6, you couldn't solve this until you multiplied this by 2 and this by 2. So you're going to notice whatever you do at the bottom, you have to do to the top. And then when we solve this, we would get 2/6 plus 1/6. And then we could simplify that to 3/6. And then we could simplify that further to 1/2. Then we would have some examples where we would have a fraction like 1/4 plus 1/5. In this case, we actually have to multiply both sets of fractions to get a common denominator. So we would have to multiply this by 5, and we would have to multiply this by 4. And then you would multiply everything. So 5/20 plus 4/20 is 9/20, which would be our final answer. So keep this in mind. In some questions, we're only going to have to multiply one of the fractions. In some of them, we're going to have to multiply both of them. And then at the end, we're going to have to simplify. Okay, we're not doing all the questions, but we are going to do all of the examples that we have over here. Starting with example number 1. So we have x/3 plus x/2. What is the common denominator in this question? It's going to be a 6. So we are going to multiply this by 2. Actually, I'm going to rewrite it. So it's going to be x/3 plus x/2. I'm going to multiply this by 2 and this by 2, and I'll multiply this by 3 and this by 3. And when I do that, I'm going to get 2x/6 plus 3x/6. Our denominators are the same, so we can add the numerators, and we end up getting 5x/6 as our final answer. Does this question have any restrictions? No, it doesn't. And the reason why is because there's no variable in the denominator. So that denominator will never be 0. You don't have to do anything to it. Okay, example number 2, we have a plus 10/6 minus 2a minus 1/30. And I told you guys last class that whenever I have binomials in the numerator, I always consider them to be in brackets. And that's important because if you keep the binomial in bracket, you will always remember that whatever you're multiplying it by, the entire binomial is multiplied by it. So if it helps, you can add in the brackets or just keep them in mind. I'm going to rewrite the question so I have a little bit more room. I'm going to write a plus 10/6 minus 2a minus 1/30. What is the common denominator in this question? 30. So we don't need to multiply the second fraction with anything. We just need to multiply the first fraction by 5. Okay, so see how I'm multiplying the top binomial by 5? I need to distribute that 5 to everything inside the binomial. So you're essentially going 5 times a and then 5 times 10. You don't have to show your work for that. You can actually just go ahead and do it. So 5 times a is 5a. 5 times 10 is 50. The second fraction, we don't have a number we're multiplying by, but remember how last time I told you that negative sign needs to be distributed to everything inside the second bracket, because the negative sign is just out. It's like multiplying by -1. So we're going to go ahead and multiply negative by 2a. So it's going to be -2a. And then -1 times -1, which is going to be +1, all over 30. But okay, so we have 5a. I'm going to now go ahead and simplify this. So I'm going to get 5a minus 2a, which is 3a. 50 plus 1, which is 51, all over 3. can this be reduced any further? Is 51 divisible by 3? The answer is yes, it is. So if you just go to the side over here, we're going to go 51 divided by 3, 21 and 7, and you're going to end up getting 17. So why is that important? Because what we can do now is we can take out a greatest common factor of 3 and solve it. Question? Sorry, yes. Okay, so I'm going to factor out a 3, and I'm going to get a plus 17 all over 30. And am I done this question? Can I do anything else? I can reduce 3 and 30, which would just give me 1, and this would give me a 10. So my final answer is going to be a plus 17 over 10. There are quite a few steps in this question, so make sure you understand what happened here. Are there any restrictions in this question where the denominator does not have any letters or variables? No, there are no restrictions, so we don't need to write anything. That's our final answer. Are you guys okay with this example? Okay, let's keep going. Example number 3. Okay, now we're getting into the more fun stuff, because in these questions, you don't have a denominator that is just a number like you did in example 1 and 2. Okay, so how do we figure this out? Well, first, I factor everything that I possibly can, and I try to simplify within each rational. So remember, we're not multiplying these, we're adding and subtracting them, which means we can't simplify from one fraction to another. However, you could simplify within a fraction here, and you could simplify within a fraction there. So I'll try and do that. I'll go ahead and factor the denominator there, which is 5k plus 20. So I'm going to get k plus 24, and then 5 times k plus 4. I factored it. I realized I can't really reduce anything, but this kind of gives me an idea of what's happening. One of my denominators is 5 bracket k plus 4. My other denominator is k plus 4. How can I make both of them the same? Yeah, if I multiply the second fraction by 5 at the top and the bottom, both of my denominators are going to match, and then I'm good. We cannot cancel out anything because there's no matching. Like if the numerator here was k plus 4, then you could have crossed it out, but nothing can simplify, right? Do you see that? Yeah. Okay, so I'm going to multiply this by 5, and I'm going to multiply that by 5. When I do that, I'm going to get k plus 24 and then k times 5 is plus 5k all over 5 bracket k plus 4. Does that make sense? Does everyone see why I just wrote 5 bracket k plus 4 only once? Because they're common denominators. I don't need to add them. Once they match, that is your denominator. You don't need to write it multiple times. Can I simplify the numerator? I can, right? Because I have a k and a 5k. So what I'm going to do is I'm going to combine those, and I'll get 6k plus 24 over 5 bracket k plus 4. Can I simplify the numerator even more? I can factor out a 6, which will give me k plus 4 over 5 bracket k plus 4. And now what can I do? Yep, I can cross out the k plus 4 and k plus 4. Why can I do that? It's because I don't have anything added or subtracted. You can cross out entire brackets if they are matching and there's nothing else like before or after it. So my final answer in this question is going to be just 6/5. Do we have any restrictions for this question? Yes, we do, because there's a variable in the denominator. Do you notice how in this question we didn't cross anything out? So if you're wondering where am I going to find the, where will I find my restrictions? It's just this step over here once you factored everything. There's only one restriction. What is it? Yeah, k cannot equal -4. Any questions about that? Question? No, because you may have reduced it by the bottom step. It's always safest to do it at the step when you factored everything, because then like it's untouched, like you haven't reduced anything or gotten rid of anything. Yes, exactly. Okay, so let's do example number 4. Again, the first step I'm going to do is I'm going to factor what I can. And the only thing I can factor here is a simple trinomial in the second question, in the second fraction. So let's go ahead and try that. Ooh, this is very, what is it? Like a fuchsia, a hot pink? Okay, so we can't really simplify anything within this rational. We can't really simplify anything within this rational, so simplifying can't be done. We have to find a common denominator. You're going to notice both of them have an r minus 1. So what do you need to add to that first fraction to make it look like the second fraction's denominator? The third? Yeah, so we're just going to multiply r plus 6 at the top and the bottom of both of the fractions here. And I do want you to show that work. So just make sure you're writing like times r plus 6 and times r plus 6. Okay, now again, we're going to multiply 4r by everything inside the bracket r plus 6. We're distributing. So you're basically going 4r times r is 4r squared. 4r times positive 6 is 24r. Everyone see how I got that? Confused or okay? So I basically just took that 4r and I multiplied it to everything inside of that bracket. Okay, for the second bracket, we have a negative sign and then a 28r. So it's just going to be minus 28r all over, and we have a common denominator. So we're just going to write that as it is, r plus 6, r minus 1. I'll tell you a common error. Sometimes because you guys are, your brains are so trained to whenever you see brackets, you want to FOIL. I'm going to say don't FOIL. For these types of questions, it's actually always better to have everything as factored as possible. So for that denominator, keep them just in factored form. Okay, don't start FOILing and distributing and stuff like that. Can we simplify this further? How about the numerator? Can we do anything to that? Yeah. Go, Aryan?
So the how you do that?
Yeah, you can factor out of 4. Okay, so I'll do it in both steps. 4r squared, this is going to give me negative 4r all over r plus 6 and r minus 1. And then I can actually factor out a 4r to get r minus 1. And then you notice that you can actually cross out the r minus 1s. So our final answer is just going to be 4r over r plus 6. So let's finish off this question by stating the restrictions. If you're wondering what step I would state the restrictions for, it would be, I mean, they all are the same because we don't cross anything out until the second last step. But I just look at this step right here once I factored everything. There are 2 restrictions. What are they? R cannot equal -6 and R can't equal 1. Okay, so those were the 4 initial examples. I also want to, I know you're going to be like, oh my gosh, it's so much. We're going to do questions 4, 11, 13, and 15 together. So let's do 4 more examples, and by then you'll all hopefully understand it really well. And then the rest of the class, you guys can just continue to work.
What about the question for like multiply one fraction after the other? Like, for example, 4 and 5 multiply them both of them, right?
Yeah, so we're gonna get to those. Yeah, hopefully. I'm pretty sure this has some of them. Okay, so let's try question number 4. So you guys, for question number 4, we have 5, 4, and 10. What do you think is the common denominator for this? It's going to be 20. Good. So I'm just going to, I'm going to rewrite it so I have a little bit more room. 9x over 5 minus 3x over 4 plus 7x over 10. And I'm going to multiply this by 4 and this by 4, this by 5 and this by 5, this by 2 and this by 2. So 9x times 4 is going to be 36x. Negative 3x times 5 is going to be negative 15x. Positive 7x times 2 is going to be positive 14x. All over 20. We can definitely simplify this. So negative 15x plus 14x is just negative 1. 36 subtract 1 is going to be 35x over 20. And I can actually reduce that fraction as well by dividing by 5. So I will end up getting a final answer of 7x over 4. Yes. Oh my gosh, this line is just not looking good. Oh, there we go. Does this have any restrictions? No. Question number 11. Okay, let's go ahead and factor everything we possibly can. I haven't seen the letter G in a question in a long time. Okay, if you're watching this, you're probably like, why am I erasing so much? It's because I have OCD issues. And so if it doesn't line up, I can't handle it. That's pretty good, right? Okay, maybe that. There we go. I'll pause here so you guys can factor. Mistake, did you guys get the following for your factoring? Anyone answers match mine? So I know I didn't make any mistakes. Okay. Now, guys, here is where I was saying that if you can simplify, you should. Take a look at the first fraction. Do you notice anything where you can simplify it a little bit to make the question easier? Okay. Yeah, exactly. So if any rational has a matching number, binomial in the numerator and denominator, you can cross them out and make the question so much easier. When you do this, look at what happens. We basically just have g over g plus 2 plus 3 over g plus 2. I'm not going to rewrite it. Hopefully you guys can just see it. Do we have a common denominator once we do that? Yeah. So we're just going to add the numerators g plus 3 or 3 plus g plus 3 all over g plus 2. Now, let's say you didn't notice that. Let's say you didn't cross it out. What would you have done? You would have probably multiplied this by g plus 4 and then this by g plus 4. And that's the really long way. You would have still gotten the same answer at the end, but why do all of those extra steps? If you can simplify a rational before you continue, always do that. It makes the question like insanely easier. Did anyone do it the other way where they multiplied by g plus 4? Did you eventually get the same answer though? You did, but so many more steps, right? Okay, let's state our restrictions. So g cannot equal -4 or -2. Okay, we're okay? Let's keep going. Question number 13. Okay, so question number 13, I'm going to start by factoring the denominator. This one's pretty easy to factor because it's just a simple trinomial in one place. What do we need to multiply the second fraction by to get same denominator and numerator? Yep, so we're going to multiply this by p minus 3, and we're going to multiply this by p minus 3. So we're going to end up getting in the numerator 5 plus, and I'm basically going to distribute that, I'm going to distribute that 1 in this bracket and in this bracket. So 1 times p is just p, 1 times -3 is just -3, all over, now we have common denominator, so it's going to be p minus 3 times p plus 2. We're not done because we can simplify 5 take away 3 is just a 2. So we're going to end up getting p plus 2 in the numerator. And then in the denominator, we'll get p minus 3 and p plus 2. Are we done? Nope, we can go ahead and cross out the 2p plus 2's. And our final answer is 1 over p minus 3. What are the restrictions for this question? P cannot equal to -2 and 3. Okay, I actually lied. The last question will not be 15, it'll be 16. And that will be the final one. And you will see why I'm picking 16 when we actually get to it. Am I going too fast? Are you guys okay? Do you still need this up? Okay, I don't see anyone writing. Let's go ahead and try 16. I'm going to pause and let you guys try this question first. This question, we have x and positive 2 and minus 1. At this step, once I'm done factoring everything I possibly can, I just look within each fraction and see if I can simplify. Remember, you can't look between, like you can't try and reduce something here and here because there's a subtraction sign. You can only do that when there is all multiplication signs. So when you did this, you probably noticed that finding a common denominator is not too difficult because they all kind of are related. In the end, we want our denominator to look like that. We want x plus 2 and x minus 1 in every single case. So for this fraction, we're going to have to multiply by x minus 1 and x minus 1. In the second one, we're going to have to multiply by x plus 2, and then this one by x plus 2. And then we don't need to do anything to the last one. So this question isn't difficult. It's just that there's a lot of places where you can make little errors. So just be careful when you're doing your distributive and all that stuff. 5x times x is 5x squared. 5x times negative 1 is negative 5x. Now for this part, you have to be really careful because this negative belongs to this x. So you're basically saying negative x times x is negative x squared. Double check your work to make sure you got the signs right. Then negative x times positive 2 is negative 2x. Okay, so again, whenever there's a negative sign, it belongs to the fraction that comes after it. It belongs to that numerator. And when you're distributing, you have to include it with it. Then we have positive 3 all over x plus 2, x minus 1. Okay, let's keep going. I'm going to simplify the numerator. 5x squared minus x squared is 4x squared. Negative 5x minus 2x is negative 7x plus 3 all over x plus 2 and x minus 1. Did you guys get that for your trinomial? So I'm on the right track? Okay, this is a complex trinomial. So let's try 4x and x, 3 and 1, negative and negative. Does that work? So 4x squared, negative 7x plus 3, all over x plus 2 times x minus 1. And then hopefully you guys remember to cross out the two x minus 1s to get a final answer of 4x minus 3 over x plus 2. I would say in our examples, this was definitely the trickiest one because we had to find a common denominator for 2 of the fractions. And then after that, it's just all distributive, collecting like terms, factoring, simplifying until the end. We have only 2 restrictions in this question, and they are x cannot equal to negative 2 and 1. Yeah. Okay, question number 1, we have 4 over 5p minus 7 over 15p. So our denominators are not the same. How can we make both of the denominators the same? Sarah? Good, we're gonna multiply the first one by 3. And the reason we're gonna do that is because we will be able to get a 15p. So I do want you to just show me somewhere on the question what you're multiplying by. It helps me when I'm marking, but also if you make a small error, I can give you part marks for it, right? So always just show whatever you're multiplying by somewhere in the question. Then we're gonna go ahead and actually multiply it. So 4 times 3 is 12. 5p times 3 is 15p minus 7 over 15p. Once the denominators are the same, all we need to do is add or subtract the numerators. So 12 take away 7 is 5 over 15p. Can I reduce this even further? Good job. 1 over 3p would be our final answer. And we can't forget about restrictions. We have a variable in the denominator, which means that we have to state what p cannot equal to. What's the only restriction in this question? P cannot equal to 0. And in a question like this, honestly, you can look in any step because it's not like we have to factor anything or simplify anything. I almost always just look at the second step when I'm trying to do my restrictions. It just always ends up working out that way. Not bad, right? Okay. On to question 3. And I'm just going to rewrite question 3 so I have a little bit more room. So it's y over 2 minus y over 5 minus y over 6. Okay, so what would be our common denominator, Noel? Yep, you're right. It would be a 30. So we'd multiply this by 15 and this by 15. We would multiply this by 6 and this by 6. And we would multiply this by 5 and this by 5. Okay, so what I'm going to do is I'm going to put all my numerators together. Y times 15 is going to give me 15y. Now you guys have to remember that if there's a negative sign, that negative sign actually belongs to this y. So it's kind of like saying negative y times 6 is going to give me negative 6y. And then the next one is going to be negative y times 5, which is going to give me negative 5y. All over, we just need to write the denominator once when they're all exactly the same. So it would just be all over 30. So we can solve this. 15 take away 6 take away 5 would give us just a 4y over 30. And can I reduce this? I can make it 2y over 15. Question? You can write it as separate terms. That's totally fine. Are there any restrictions in this question? No, because there's no variable in the bottom, which means the bottom can never, ever be 0. So we can just write no restrictions, and that's it. Question? It really depends. So in the first question, when I was doing my restrictions, I noticed I wasn't factoring, they're just monomials. So I just look at the denominator and I know it's probably going to be zeros. I just write down zeros. In this one, I look at the original question. There's no variables in that in the denominator, so I will not have any restrictions at all. I do, and then sometimes if I can factor it, then I look at it in factored form. Okay, let's keep going. We're going to skip to question number 6. Okay, question number 6 is a great example because I want to bring your attention to something when we do this question. My first strategy is before I even try to find a common denominator, I'm going to factor if I can, and I'm going to try to simplify as much as I can. And I'll show you what I mean. The only thing I can really factor in this question is this 2n plus 8 over here. So I'm going to rewrite it as 5n plus 9 over 12 minus 2 bracket n plus 4 over 16. Okay, are we allowed, I know in this question we probably couldn't, but are we allowed to simplify a 2 and a 12 if there's a subtraction sign? The answer is no. The only time you can do that is if there's a multiplication sign, but if there's any other sign, you can't. So we can't do that. But are we allowed to simplify things that are within a fraction or a rational? The answer is yes. So you cannot do it between them if there's a addition or subtraction sign, but you should always try to simplify within a rational expression by itself. So what can I do in this question? Well, I can simplify the 2 and the 16 to give me 1 and 8. And by doing that, I actually make the question a lot easier. Okay, so when I do that, I will end up getting 5n plus 9 over 12 minus n plus 4 over 8. I don't know if that's a lot easier for you, but I think 12 and 16 are pretty big numbers. I think 8 and 12 seem a lot more manageable. What is a common denominator for 12 and 8? Tanisha? Yep, so I'm going to multiply this by 2. Now, here's another thing that you should recognize. If you have a binomial in the numerator, make sure you always put brackets around it. Because when you're multiplying the top by, for example, 2, you actually have to multiply the entire bracket by 2. How about for the second fraction? What am I going to multiply the top and the bottom by? 3 to get 24. Good. So I'm going to multiply this by 3, and I'm going to multiply this by 3. I'm going to do this next part super slow. It's super important. And if you understand this, then the rest of the questions become really easy. Essentially, what I'm doing now is I'm taking this 2 and I'm distributing it between everything inside this bracket. So let's start by doing that. It's going to be 5n or 2 times 5n, which will be 10n. And then it's going to be 2 times positive 9, which is going to be 18. Okay, now for this next bracket, I have to remember multiple things. First of all, I have a negative sign, which belongs to this bracket, and I'm also going to be distributing that 3 inside of this bracket here. And I'm going to try to do it all in one step. So it's kind of like saying, okay, so we have negative 3 times n, which is going to give me negative 3n. And negative 3 times positive 4, which is going to give me negative 12. So you're basically thinking of the 3 being over here, and you're multiplying everything inside the n plus 4 with a negative 3. Did that part make sense? Any questions about it? You have to be really careful about this step right here, because there's that negative sign, and if you forget it, then it can kind of mess up all the other signs. What is our denominator going to be? Just 24. Okay. The tough part is done. Now we can collect like terms. So I'm going to have 7n 6 plus 6 over 24. I can't simplify this any further. I can't factor it. I can't do anything. So that actually ends up being my final answer. That's it. Do we need any restrictions for this question? Nope, there's no variables. That's the question. That's the answer. Okay, how are you feeling about this? Good. We're going to do maybe 3 or 4 more examples, and then you guys can just work on the rest of the sheets yourselves. So let's try example number, I'm picking 12, 14, 15, 16. Those are the 4 that we're doing if you're working ahead. Let's start with question 12. Okay, so if you're someone who's like, what are the steps? Well, step number 1 is going to be to factor everything you possibly can. Okay, great. So now, how can I make these denominators the same? I have a plus 5 and a plus 1 in one bracket, and then I have an a plus 1 by itself in the other one. Marzu? Yeah, you're gonna have to multiply by the entire bracket of a plus 5. So the way I show that is I just write times a plus 5 times a plus 5. I do want to see this step. I want to know what you're multiplying by. Just make sure you just write it small somewhere. Raymond, you had a question? You can't because they're both in the denominator. And also there's a plus sign, so no. Okay, so now in the next step, I'm going to have 4a, and I'm going to multiply the 1 to everything inside of this bracket. And luckily, it's a positive, so we don't have to worry about any negatives. Every sign stays the same. So 1 times a is just going to be positive 1a. 1 times 5 is positive 5, all over. And because the denominators are now the same, we just have to write them once. It will be a plus 5 times a plus 1. So this part right here, because now it's a common denominator. So it's kind of like, you know, when we had 1 over 3 plus 1 over 6 or something, then when we multiplied this by 2 and 2, this now becomes whatever this one was. So because the first fraction is a plus 5 times a plus 1, the second fraction is also going to be exactly the same, and that will be your official denominator. Can we simplify the numerator some more? Yep, 4a plus a is 5a plus 5, all over a plus 5 and a plus 1. Can I simplify some more? Yes, I can take out a greatest common factor, and then you should be able to cross something out, which is always very nice. I like when things cross out. So when I factor out a 5, I get 5 bracket a plus 1, and then our denominator is still a plus 5 and a plus 1, which means I can go ahead and cross out my a plus 1s, and all I'm left with is 5 over a plus 5. Are you okay? There's like something going on back there. You guys, what are the restrictions in this question? Just look at the second step then. A can't equal to -5 or -1. Where's it? Okay, so I'm going to factor this. All right, so I know it seems like 8z minus 15 is factorable, but it's not. So all I did was I factored 4z squared plus 11z minus 3, and that's what I got. And what do you think we have to do to the first fraction to get to the second one? Sarah? Yep, so I'm going to multiply this by z plus 3, and I'm going to do the same thing over here. I'm going to multiply that by z plus 3. And when I do that, I'm going to have a denominator that is the same. It's going to be 4z minus 1 and z plus 3. Okay, what does this mean for our numerator? Well, 4 times z is 4z. 4 times positive 3 is positive 12. And because this is a plus sign before the 8z minus 15, nothing changes, no signs are different. So I can just rewrite it as 8z minus 15. In the next step, I'm going to add up the z. So 8 plus 4 is going to give me 12z. Positive 12 minus 15 is going to give me minus 3 all over the denominator. Can I keep going? Yeah, I can factor out a 3 and then hopefully something should cross out. So I'm going to factor out a 3 and I'll get 4z minus 1 all over 4z minus 1 and z plus 3. Then I can factor that out. I'm sorry, cross that out and that out. And my final answer is going to be 3 over z plus 3. What are the restrictions in this question? Okay. Very close. -3 is definitely right. But look at this bracket over here. It's 4z minus 1 cannot equal to 0. 4z cannot equal to z cannot equal to 1 over 4. It's going to be 1 over 4. Because they're two numbers. Yep. So as soon as you see two numbers, you know it has to be something. Okay, so z cannot equal to -3 and it cannot equal to 1 over 4. Yep. Question 15. I didn't think question 15 was a good one, but it's turning out to be a really good one. Okay, so we're going to first factor everything. It's going to be r and r. And let's do 6 and 2. 6 and 2 is not going to work. There might be textbook questions. I'll double check.
No.
Okay, sorry, I'm back to this question. Okay, so r squared plus 8r minus 12. I can't find a way to factor this. I don't think this is factorable. You can try 6 and 2 and it's not going to work. Yeah, but were you guys able to factor this? No. And it doesn't work, right? Yeah. Okay, yeah, so we're not going to factor this. We're going to go r squared plus 8r minus 12. And then the bottom is just going to, let's see if we can factor the denominator. 2r, and this will be 3 and 1. That's fine. And it's going to be I don't think so. I think only this would work. Just redistribute it and see if it'll actually work for you. Okay, then I'm going to multiply this by 2r plus 1, and I'll multiply this by 2r plus 1. So my numerator will become r squared plus 8r minus 12. And then this will become minus 6, not squared, minus 6r minus 3 all over 2r plus 1 and r minus 3. I can simplify that. So it's r squared plus 2r minus 15 all over 2r plus 1 and r minus 3. And then I should be able to factor this now. I hope. I have r, and then I can have positive 5 minus 3 all. So then we're going to cross that out and cross that out. I believe the answer should be r plus 5 over 2r plus 1. And the restrictions for this one are going to be r cannot equal to -1/2 and r can't equal to 3.